And I said yesterday that this was section 2.5. It's actually 2.6. So we know where we are. So we'll talk about slant asymptotes. And the other way that you might hear about them is they'll use the word oblique. A slant asymptote or an oblique asymptote. But really quickly, before we talk about slant asymptotes, we'll just recap asymptotes, the information that we need for our asymptotes. So if we have our function, we have our rational function, and we call whatever the polynomial that's in the numerator is n of x, and d is our denominator, d of x. For our asymptotes, if the degree, and I'm just going to use the abbreviation DEG, degree of n of x is less than the degree of d of x, the degree of the numerator is smaller, then y equals 0 is a horizontal asymptote. If the degrees are equal, so that was our first case. If the degrees are equal, degree of n of x, and I'm just going to write n, I'll write n of x equals the degree of the denominator, d of x. Degrees are equal, y equals the ratio of the leading coefficients. Is the horizontal asymptote. And I'll put this in quotes because we need to calculate that ratio of leading coefficients. So those were the two main ones that we worked with last night. Our third one we said the other day is if the degree of the numerator is larger, then we don't have a horizontal asymptote. But we did say that something special happens in certain cases here. And just off to the side here, I'm going to say where the denominator equals 0, where the denominator is 0 are vertical asymptotes. And it doesn't have to do with the asymptotes, but we said there's a hole in the graph if the numerator and denominator are 0 at the same time. So if we have a factor, if we get parentheses and we cancel the parentheses out of the top and the bottom, whatever x value makes that each of those parentheses 0 is going to give us a hole in the graph. So we're kind of canceling that number out of the graph is the way you can think about it. Well, let's look at this special case where the degree of n of x is greater than the degree of the numerator is bigger than the degree of the denominator. In a special case, we get what we call a slant asymptote. If the degree of the numerator is 1 more than the degree of the denominator. We get a slant asymptote. And we find the slant asymptote by using long division. So if our degree of our numerator is 1 more than the degree of the denominator, we have a slant asymptote. And a slant asymptote just means rather than a horizontal line, our asymptote is some slanted line. And we find the equation of that slanted line by using long division. Yeah?
Did you use synthetic division?
If you're remember, if to use synthetic division, we have to divide by something like x minus c. So if you were dividing by something that just is x minus c, you could use long division. But if you were dividing, like the example we did in the homework where we had x squared minus x minus 2,
Right.
you couldn't use synthetic division for that.
Got it.
So in special cases, you can use synthetic division. Normally, you'll have to use long division. All right, so let's look at a quick example of finding a slant asymptote. Just a process that we go about it. So if we were to, our problem was to sketch y equals x squared over x minus 2. So we would go through the same process that we used on all of our examples. We can find the x-intercept, we can find the y-intercept. I'm not going to go through all of that again because we've practiced on that process already. We're going to have a vertical asymptote where the denominator equals 0. Vertical asymptote where the denominator equals 0 is at x equals 2. The degree of the numerator is 2. The degree of the denominator is 1. So that tells us we have a slant asymptote. The degree of the numerator is 1 more than the degree of the denominator. So we have a slant asymptote, and we'll do it both ways. I'll do long division and we can do synthetic division. Just so we see, because we do need to know how to do long division sometimes. So our slant asymptote, we just divide this. So I'll do long division first. X minus 2, and we're going to divide x squared. And I can say plus 0 if we want to. So x goes in x squared x times. I get x squared minus 2. Minus 2x, yes, thank you. And then I'm going to subtract. X squared minus x squared is 0. 0 minus negative 2x is, is 2x. 0 minus negative 2x, we get 0 plus 2x is 2x. And I get a plus 0 there. X goes into 2x 2 times. So when I multiply, I get 2x minus 4. Subtract, I get a 0. 0 minus negative 4, I get plus 4. So my remainder is 4. My slant asymptote is this part up here. I just ignore the remainder and I use whatever I get up here. So the slant asymptote is y equals x plus 2. That's my slant asymptote. So I just do my division, I use everything except for the remainder, and that's my slant asymptote. And because this function, we are dividing by x minus 2, we could use synthetic division. So we could say we're dividing by 2. So I'm just going to do that here, 2, and my function is 1. I'm going to put a couple zeros. So 1, 2, whoops. Bring that down, that's a 2. 0 plus 2 is 2, and that's a 4. So my remainder is 4, and I get x plus 2 here as well. So that's my slant asymptote. And if we were to sketch a graph of this, I'm not going to go through finding all the points, but what a graph of a rational function with a slant asymptote looks like. We have a vertical asymptote at x equals 2. So here's my vertical asymptote. I would graph the line y equals x plus 2. So that line would look like something like this. So there's my slant asymptote. And my function ends up going in between these two. And I would figure out the exact shape by plotting points. My function ends up looking like this and like this. I have an intercept at x equals 0, so it goes through 0, 0, and I would plot some additional points to see that my function goes between the vertical and the slant asymptote like this. The x-intercept is where the numerator is 0. So I set the numerator equal to 0. The y-intercept, I plug in x equals 0, and then solve. Okay? So slant asymptote, you find your slant asymptote if the degree of the numerator is bigger by 1. You find your slant asymptote by division. You divide everything, and you throw everything away except you throw the remainder away, and you keep everything else, and that's your slant asymptote. The line y equals whatever that is. Are you good? The numerator.
Set it equal to 0, or you try to make it 0, right? What makes it 0?
Same thing.
Is it the same thing?
Yeah.
If you got, I guess it is.
Yeah. So the x-intercept is where the numerator equals 0. So you set the numerator equal to 0.
On the bottom, the y-intercept is
Put 0 in for all the x's. Yes. All right. So today, what I have today is I'm going to give you the problems that we skipped from yesterday. So page 174, number 51 through 57, odd, and I have this rational function worksheet. So both of those are your homework.
how many questions are there on that
Some of them are multiple choice. A lot of them are multiple choice, and there are 27.